Good morning everyone, I am Renu Sharma, Assistant Professor EC Department. Today I am going to start with the next lecture that is related to the handoff strategies. So, these are the contents of today's lecture, that is first one is we will discuss what is handoff, then types of handoff, classification of handoff and strategies behind handoff. So, before we will begin with this topic, first we will see what is handoff, its introduction, what it is all about in wireless and mobile communication. So, when a mobile moves into a different cell while conversation is in the progress, the MSC automatically transfers the call to a new channel belonging to new base station is known as handoff. So, basically what will happen, that I have told you that every geographical area is divided into different cells, small cells, which is of hexagonal in shape like this one. So, each of the cell, or you can also say each of the subscriber which is residing in that particular cell, belongs to that cell, is act as a home location register for that particular cell, which has all its authentication information, all information that is related to that is required to make the connection, to set up the connection between the transmitter and receiver. So, another thing is that when a call is going on, then a particular person moves from one cell to another cell, means it is moving, then the control signals will be transferred from one BSC to another MSC, or you can say one MSC to another MSC, that is the mobile switching center, and that is known as handoff, means transferring of the signals or the control signals from one cell to another cell when the subscriber is moving. And it is also possible that the call is going on, or it may be possible that call is not going on, but it is moving, means after reaching that destination, then it can make a call, it can proceed a call. So, that is also known as handoff. So, that is what it is written in the first statement. Now, second one is handoff operation not only involves identifying a new base station, but also require that the voice and control signals be allocated to channels with the new base stations, which means that I am moving from one cell to another cell. The initial cell is known as home location register and the new cell is known as visitor location register, to which you all have learnt about the word, that is listen the word, that is roaming. My phone comes under roaming, which means that another call charges, another type of call charges will be made. Secondly, it will be transferred from one base station to another base station, that is the voice and control signal. So, that is required for making the handoff procedure smooth. So, that is the case of handoff. Now, handoff must be performed successfully as infrequently as possible, because during the call which has been going on, if you are proceeding for a handoff, then it may be possible that call will be terminated, because before the handoff has been made, the call will be, the control signals or the strength of the signal will be reduced. So, that is why it cannot maintain the call. So, that is why it is terminated. So, that is the main drawback of handoff. So, it is advised that when a call is going on, the person should not move from one place to another place. That is the basic requirement to maintain the call. Now, for this, system designer must specify an optimum signal level at which to initiate a handoff, which means that at what particular voltage level we have to consider, so that a proper handoff will be maintained. So, once a particular signal level is specified as the minimum usable signal for acceptable voice quality at the base station, then it has set up a threshold above which the particular signal will be considered, and after that level is crossed, then the signal quality will be maintained. Now, this margin or threshold is given by this formula, that is delta is equals to PR, that is the received power at the handoff minus received power, that is minimum usable. So, that is the very basic formula related to the margin or the threshold value, that is denoted by delta. This is very important formula. Now, this diagram is basically showing the handoff strategy. You can see there are two cases. First one is the improper handoff situation, second one is the proper handoff situation. So, what are these two cases, we will see. So, this is the received signal level versus time graph is shown over here. This is the level which is received at point A, then handoff threshold will be there. Then after that there is minimum acceptable signal to maintain the call. So, this you can see that the slope of the signal is decreasing in nature, and in this case the proper handoff has not taken place. So, this is the level at point B, that is call will be terminated. Now, in case of the proper handoff situation, which is the main aim of doing the handoff, so that the call will not be terminated if it is going on. In that case, you can see that this is level at point B, then after reaching this will be the level at which the handoff is made and call properly transferred to the base station 2. So, basically before the call is terminated and during the call is ongoing, then the signals will be transferred from one base station to the another base station, that is denoted by BS2, that is base station second. So, that means this you can see in this diagram, this is cell number 1, this is the parent cell, and this is the, you can say, the visiting cell, and the control signals has to be transferred from this base station 1 to base station 2, and this is the whole procedure that has been going on. So, in the second case the proper handoff has been taken place. Now, there is a formula that I have shown you, that delta is equals to PR handoff minus PR minimum usable. So, we have to choose the delta value very correctly. It should not be too large and it should not be too small. So, what are the two cases if we consider? If we consider it too large, then what will happen? If it is too large, then unnecessary handoffs are there and which burden the MSc. Every time the handoff has been made, means the control signal transferred from one mobile switching center to another switching center, then it will going to burden the MSc, that is the main mobile switching center. It will going to change the control signals from one place to another cell, another place. The second will be the case 2, that is when delta is too small, then there may be insufficient time to complete a handoff before a call lost due to weak signal condition. So, which means that the call will be dropped or it will be terminated on its own, because the proper signal strength will not be maintained during the call transferring or the control signal transferring operation. Call drop event will happen. So, case 1, when there is an excessive delay by the MSc in assigning a handoff, the excess delay may occur during it will be occur during the high traffic density due to the computational loading at the MSc, and it will also occur due to the fact that no channels are available on any of the nearby base stations. So, these are the two points that has to be kept in mind when we are dealing with case number 1, when delta is quite large. Second case is when delta is small, when the threshold delta is set too small for the handoff time in the system, then the dwell time, that is the time over which a call will be maintained within a cell without a handoff, is called as a dwell time, and after the handoff threshold has been there. So, that dwell time is very important term when we are dealing with the handoff. Now, next will be the types of handoff. So, what are the different types of handoff that we will come across? Like first one is the intra cell intra BSc handoff, another name is handover. We can call this handover also, because we are handovering the control signals from one base station to the another base station. So, the first one is intra cell, means within the cell and within the same BSc we are transferring the control signals or voice signals. Second one is inter cell intra BSc, which means different cells are there, but the same BSc, because more than one cell will be considered under one BSc. So, that is the concept behind cell infrastructure. Third one is inter cell inter BSc, means different cell will be there and different BSc is also there. Fourth one is inter MSc, means between two MSCs, which is a higher level as compared to the BSc. So, the first one will be the intra cell intra BSc handover. So, smallest of the handover is intra cell handover, because why we are calling it is smaller, because it will take very less time, because we are moving within the cell and within the same base station. So, the transferring of the control signals from one place to another place will it is not hectic. So, you can see in this diagram that this is a cell which consists of a BSC, that is the base station controller, which comes under this BTS, that is base transceiver station. Then it is covered by this MS, that is the mobile system, that is mobile. Okay, so this you can see that the signals will be transferred from old channel to the new channel, which is covered under the same cell. So, in this case the BSC controlling the cell makes a decision to perform the handover. So, this is the concept of intra cell intra BSC handover. Second one is the inter cell intra BSC handover, which is the subscriber moves from cell to cell 1 to cell 2, but within the same BSC. So, you can see over here that the BSC is common between these two cells, and the information means the control signals. This is the serving base station and this is the transfer to the new BTS in the same BSC. So, that is the concept behind this, where two cells are considered and which are covered under single BSC. So, in this case the handover process is carried out by the BSC. Traffic connection with cell 1 is released when the connection with cell 2 is set up successfully, and that is the case of figure 3rd, that is inter cell intra BSC handover. Third one is the inter cell inter BSC handover. Now, you can see over here that there are two cells are considered and two different BSCs are there, which is covered under one MSC, that is the central unit, which will going to control the 2 BSC, 2 BTS and the 2 cells within which the call transferring has to be made. So, the subscriber moves from cell 1 to cell 2, which is served by another BSC. In this case the handover process is carried by the MSC, but the decision to make the handover is still done by the first BSC. So, what is the decision that has to be taken when the call is transferred from one point to another point? So, that is the case that has to be led by the first base station, that is the initial base station. Now, third one is the traffic connection with the first BSC and BTS is released when the connection with the new BSC and BTS is set up. So, that is the successfully transferring of the call from one base station to the another base station. Now, third one is the inter MSC. Now, you can see over here that two MSCs are connected to a single GMSC, that is nothing, it is a GMSC, that is the global mobile switching center. Then the subscriber moves from cell 1 to cell 2, which is served by another MSC. In this case the handover process is carried by the GMSC. The traffic connection with the first BTS, BSC and MSC is released when the connection with the new BTS, BSC, MSC will be set up. So, that is the connection that has been set up. This is cell 1, this is cell 2nd, this is the serving base station, this is the receiving base station, receiving cell or the receiving unit. So, the call will be transferred from this point to the another point, that is from one cell to the another cell. Now, next one is the classification of the handoff. So, the handoff will be classified into two categories. First one will be the hard handoff, second one is the soft handoff. In case of hard handoff, it is also known as break before make, which means the connection has to be set up first, then the previous connection has to be cleared or it should be removed. So, this is the concept. You can see in this figure that there are two cells are considered. This is the connection of breaking the channel and new channel connection from the new BTS. So, this is the concept of cell 1 and cell 2. So, it is one in which the channels in the source cell is released and only then channel in the target cell is engaged. So, thus the connection to the source is broken before the connection has been set up to the target is made. So, this is the concept in classification of the handoff. Now, the hard handoff are intended to be instantaneous in order to minimize the disruption to the call. So, that is the case of classification. Now, it is not necessary that there is always a connection between the base station and the mobile station. So, that is the concept that we have to consider, that there is not always necessary that the connection will be set up before it has been broken, means with the previous one. So, that is the concept of hard handoff. Now, second one is the soft handoff. In this it is make before break, which means that the connection should be make before we are removing the particular connection that has been set up before. So, it is one in which the channel in the source cell is retained and used for a while in parallel with the channel in the target cell. So, that is the main reason why we are considering this. Now, thus the connection to the target is established before the connection to the source is broken. Now, in this kind of handoff, there is always a connection between the base station and the mobile station. So, that is the main aim of doing this soft handoff. So, this is the classification of the handoff, hard handoff and soft handoff. Now, the next one is strategies of handoff. So, we have seen what is handoff, we have seen types of handoff, which are 4 types, then we have seen classification. Then we will move to strategies of handoff. So, first one is the network assisted handoff, second one is the mobile assisted handoff. So, it is self explanatory, these two things, that what is network assisted, which means that it is being assisted by the network which has been set up for transferring the call. So, it is used by first generation analog cellular system, it is short form, it is known as AMS. First generation is related to AMS only, where we are talking about the analog communication, that is analog cellular system. So, in this type of handoff, the base station constantly monitors the signal strength of each of the mobile user and report to the MSC, which makes the decision to hand off, which means that every time the call has been set up, the base station will going to monitor the strength of the signal, and it will going to report the MSC that whether it has required any transferring of the control signals or it does not require. So, in addition to measuring the RSSI, that is the radio signal strength measurement of the calls in the progress within the cell, a spare receiver in each base station called that is called as a locator receiver is used to scan and determine the signal strength of the mobile user which are in neighboring cells. So, what does it mean, that when we are talking about this one, it will going to transfer the call from one point to the another point. So, the locator receiver is controlled by the MSC and is used to monitor the signal strength of the user in neighboring cells which appear to be in need of handoff and record of RSSI values to the MSC. So, this is the main requirement of the cell that we are talking about, that is RSSI. This is network assisted handoff. Next one is the mobile assisted handoff, and in short form it is known as MAHO. So, in this handoff, every mobile station measures the received power from surrounding base station and it will continuously reports the result to serving base station. Now, in this a handoff is initiated when the power received from a base station of the neighboring cell begins to exceed the power that has been received from the current base station by the certain level or for a certain period of time. So, it is the basic explanation of mobile assisted handoff. So, in this method it will enables the calls to be handover over between the base station at a much faster rate than the first generation system, and since this handoff measurements are made by each mobile and MSC, it no longer constantly monitors signal strength. Therefore, it will going to burden the MSC that has been reduced. So, that is related to mobile assisted only. So, what actually means mobile assisted? Mobile assisted means that when we want to transfer the control signals from one base station to another base station, then the transferring should be made very smooth, so that the call will not be terminated on its own. Secondly, it will going to it will be initiated by the mobile phone itself. It is not initiated by the network, where every time the base station will going to monitor the system and it will going to report the MSC. Then MAHO is particularly suited for microcellular environment where handoffs are more frequently. So, basically in very frequent nature this will be considered, that is MAHO. So, it is the cellular, which microcellular means we have reduced the size of the cell, because if we are going to reduce the size of the cell, then the handoff's probability will be quite large, which means that we have to move from one place to another place. Whereas, if we are considering the size of the cell quite large, means the radius of the hexagon is large, then the number of times the handoffs will be made will be less. So, that is inversely proportional to each other. Now, the next one is the prioritizing the handoff or guard channel concept. What is guard channel? First, we will discuss that thing. Guard channel means when we are transferring the information in terms of frames, then guard bands are inserted both in case of TDMA, that is time division multiplexes, and frequency division multiplexes. In both the cases, these guard channels will be inserted, so that the intersymbol interference will not take place. Now, what is intersymbol interference? When we are transferring the information from one place to another place, then dispersion of the pulses will be there. It will cause mixing of the information between the two users. So, that is known as guard channel concept. So, what it will be? It is prioritizing the handoff. So, here some of the channels of total available channels is reserved for handoff request from ongoing calls, which may be handoff into the cell, which means a band of signals, a band of frequencies has to be allocated every time, because your mobile phone is nothing, it is a mobile is full duplex in nature, means we are considering the full duplex concept in mobile communication, which means a pair of frequencies has to be allocated. One frequency is allocated for forward channel transfer, and other frequency is allocated for the reverse channel transfer. So, in both the cases this full duplex concept will be considered, and it will be in some set of, let us say I have issued 4 megahertz for forward channel and 4 megahertz for reverse channel. Now, among this 8 megahertz of information, 8 megahertz of frequency, some of the frequency will be allocated for the purpose of handoff, because every time the handoff has been made, we require extra set of frequency. So, that is reserved for this thing. Now, guard channels however offer efficient spectrum utilization when dynamic channel assignment strategies are made. So, which minimizes the number of required guard channels by efficient demand based allocation are used. So, basically we are considering this prioritizing the handoff, which means that we are basically engaging some set of frequencies from the allocated frequencies for the purpose of handoff. Now, next is queuing of handoff request. So, it is another method to decrease the probability of forced termination of calls due to the lack of available channels. So, queuing of handoff is possible due to the fact that there is a finite time interval between the time the received signal level drops below the handoff threshold and time the call is terminated due to the insufficient signal level. So, which means that when we are prioritizing the call or when we want to transfer the call, so queue will be made, which means that we can queue the request. We can make queue means in case of congestion or traffic control management. Traffic in communication means bits that we are transferring. So, queue will be set up, means a handoff is going on and the second handoff is to be initiated. So, it will be inserted in a queue. So, it is possible due to the fact that a finite time interval between the time the received signal levels are dropped below the handoff threshold and the time the call will be terminated. So, this is the time duration between which the call will be queued. So, that is our handoff will be queued. So, that is the concept of queuing. So, prioritizing on a whole is meant that a set of frequencies will be allocated or will be reserved for the purpose of handoff, so that the particular transmission or the particular transferring of the control signals will be maintained and it will not going to terminate the call in between. So, that is the concept behind prioritizing the handoff, means we are before settling up the network, we have initially allocated some set of frequencies if the handoff will be maintained is initiated between the call. So, before that we have discussed about strategies of handoff, which is mobile assisted and the network assisted handoff. So, in this lecture we have discussed about handoff, which means we are moving from the parent cell to the visiting cell, which is from home location register to the visitor location register, and how these steps will be followed, what are the different types of handoff, whether we are moving from one cell to another cell or within the cell, or moving from one BSc to another BSc, or from one MSc to another MSc. So, we have discussed all these topics related to the handoff. So, these are the references that you can go through for this particular topic. Thank you.